after the partition of the both parts, now we are going to go ahead and start with the next module, properties. Here first we are going to define the properties, and then we are going to create the sectional and apply those properties to different section of the part. But before that, I'm going to show you what kind of properties we have used in our model. Alright, so these are the properties we will be using in our numerical model. So these properties came here from the centrifuge test. As you can see, soil with the density of 1550 kg per second, Poisson ratio, and friction angle, dilation angle, cohesion real stresses, and ABS plastic strength. So all these properties we'll be using for the soil layer, but the elastic modulus of the soil will be changing as per the shear wave velocity curve, and we have calculated the elastic modulus for each layer from the shear wave velocity. So we will be using the E value or the elastic modulus value from here for the soil, and from 5% damping ratio we have calculated the alpha and beta for the damping. And for the building we will be using these properties. The material of the building is aluminum, used in the centrifuge test with the density of 2700 kg per meter cube, and the elastic modulus is this much, and the Poisson ratio with 0.33. So these are the properties we will be using in the numerical model. How we will create the properties, let me show you. So here in the property module we have different options. First we are going to go and create a material. So now you can name a material. So I am going to name it as so let's create the soil properties first. Soil layer 1. Okay, so now we are going to add the material behavior into it. First we start with the density. So in our case the soil density was 1550. Okay, and then we are going to go with damping, and for the 5% damping ratio our alpha and beta values were, I'm going to copy it from here, 0.76933, 0.76933, and the beta value was 0.001805. So it's 0.001805. Okay, and now we are going to add the elastic properties, which is the Young's modulus. The Poisson ratio was 0.3, and the first layer elastic modulus, I'm going to copy it from here and paste it in the Abaqus. Okay, and now we are going to add the plastic properties, because we are using the non-linear model, and for that we will be using a Mohr-Coulomb plasticity model. Okay, and as we know our friction angle was 40 and the dilation angle was 10, and the cohesion yield stresses was 3000 from the test, and we will keep the absolute plastic strain for now 0. Okay, and press OK, and now you can see you can go ahead into material manager, and here you can see we have created the properties for soil layer 1. So in the similar way I am going to add the material properties for all 36 layers, and once I am done I'll be back with you. Alright, so we have created the soil properties for each layer all the way to soil layer 636, And after creating the material properties, now we are going to create sections of these properties, which we will later on apply to the different parts of our model. So in order to create a section, we can click here on create section. We can name this section by a property called aluminum, and we can keep it as a homogeneous layer. So in here we will select the properties for which we created the section. So we created the section for aluminum, so we are going to select the properties of aluminum, and then press OK. And now here you can see that we have created a section, and similarly we can create the section for the rest of the soil properties, like for soil layer 01, and then press continue. Then here we select the layer properties of soil layer 1. As you can see, we have created the properties. So I will create the sections for all 36 layers, and I'll be back in a minute. Okay, so we have created the material section for all the properties we created, all the way from the aluminum properties for the structure and the soil properties for all the 36 layers. Okay, so after creating a section, now we will going to apply these properties. And how we are going to do this, we are going to go to the assign section, click on this. You can create a nodes, but we don't need to create a nodes for this one. So first I'm going to assign sectional properties for the building. So I am going to select the whole building and done. And here you can see we can go to the drop down list, and in this list we are going to select the aluminum. Okay, and then we are going to click OK. So now you see the color has changed from white to green. It means that we have assigned properties to the structural part. Similarly, we are going to assign properties to the soil part, and which is different layers. So how we are going to do this, we are going to create a section, click on assign a section. Okay, and then we are going to select the layer first. Okay, alright, and then we are going to select the soil layer 1, click OK. So as you can see, the soil layer 1 properties colors change from white to green. And you can do the similar thing by continuing selecting the second layer, click done, and select the soil layer 2 for the second layer and click OK. Similarly, the Abaqus is also continuing this command. Select the region, so we are going to select the layer 3, done, and we are going to select soil 3. Okay, so in this similar way we are going to assign the properties to all the layers, and I will do that in a quick way and will be back to you. Okay, so all the properties of the soil layer has been assigned to different layers. You can see this assigned section in the sectional manager, and here you can see the list. For example, if I double click on the soil layer 36, here you can see the highlighted region. And then if you want to check the layer 23, double click on that and you can see the highlighted region. So all the properties for two different layer has been assigned, and you can see them by different color as well. As you can see, the different colors mean different properties are assigned to the different layer of the soil. So we are gonna keep it as default.